In this video, we're going to do a walkthrough of a kinematic problem, and I basically want to show you how to set up your paper for any of these problems, whether it's a horizontal, vertical problem, a two-dimensional projectiles problem. Anytime you're doing a kinematics problem, you're going to want to set your paper up this way. So we'll start with this problem here. An Indy 500 race car's velocity increases from 4 meters per second to 36 meters per second over a 4-second period. What is the average acceleration and its displacement over this time interval? So the first thing we want to do is we want to set up all of the different possible variables that can happen in kinematics problems. So I'm going to write them over here on the left side of my paper. We're going to start with V initial, and you can actually write that as V sub I or V sub what looks like a little 0 or O. It's V naught. I use it interchangeably. You'll see it written both ways depending on who's writing the problems. We can use V sub I. We're going to do V sub F for V final, for final velocity, displacement, acceleration, and time. All right, so we're going to figure out what are we given and what are our unknowns. Well, our unknowns, again, we're being asked to find average acceleration and displacement. I'm going to throw a little bar over the acceleration A here so that we can denote that that's an average. And I'm going to put a question mark there because we don't know what that is. We're trying to find it. I'm going to do the same thing there for displacement. And it's really important to remember that this D in these kinematic problems is displacement and not distance. That's huge. So remember, this is always going to be displacement. All right, so we are given a couple velocities. We're told that the car's velocity increases from 4.0 meters per second to 36 meters per second. That tells us it starts off at 4 and it goes to 36. So its initial velocity is going to be 4.0 meters per second. Always put units in here. You always want to put units to identify the units of the particular value. And final velocity, 36, again, meters per second. And that happens over a 4.0 second time interval. So we have all of our possible variables, either givens or unknowns, figured out. The next step is to then figure out, well, which kinematic equation are we going to use? Now I have a small cutout right here that I'm just using for reference. You don't need to write these on your paper, all of them at least like this every single time. You will write the one that you are using for the problem though. So if I look at the kinematic equations that are listed here, I want to find the one that's going to work for what I'm trying to solve for. So the first thing I'm going to solve for is going to be acceleration. So I'm going to put that just like that here to identify what I'm working on. And so I'm going to look for an equation that has variables in here that I do know and also acceleration. And so the one that works out best is going to actually be this first one listed right here. I know V final velocity, I know initial velocity, and I know time. And that leaves one unknown, and that is acceleration. So I'm going to write that equation before any substitution. V final equals V naught plus A times T. All right, so again, I'm writing it as it is without any substitution to identify which equation I'm using. Then I'm going to substitute values in. I know V final is 36, and I'm going to leave units off to keep this kind of clean as I do my math. V naught, or V initial, is going to be 4.0. And again, V naught and V initial, I'll use them both. I really should be using the same one within the problem. So just know that, V naught does represent initial velocity. And that is plus an unknown acceleration multiplied by, well, I know time is 4.0. So there's my substitution. And then the last step is to write my answer, which is going to be A equals, and it's calculated to be 8.0 meters per second squared. Again, units super important, and also important, you put a box around it. All right, so that's my final answer. Units, sig figs are accounted for, 2 sig figs, and a box. Now, since this is a two-parter, I'm going to draw a line under this portion of the problem, and then I'm going to specify, well, now I'm trying to find that unknown displacement. And it's the same idea. I want to look for an equation that has values that I know and also include my unknown displacement. And so when I look down here, I find that this equation is going to work. I have my unknown displacement. I know V naught, I know V sub f or V final, and I know time. So as I did before, I'm going to write the equation that I'm using. V naught plus V final times time. There's my equation, and now I'm going to substitute in values. Well, I don't know what displacement is, so I leave it as its variable letter. 1/2 V naught is equal to 4.0, V final 36, and that is multiplied by 4.0. And then finally I'm going to write my final answer. Displacement is equal to 80 dot meters. And I need to put a box around that. There we go. And then last thing, I'm going to draw a line under the entire problem so that I can start my next problem below that, and it's very clear where the next problem begins. So set all of your problems up like this. It should be this format every single time, where you have your variables on the left side, your givens and your unknowns. They're all listed there. I'm going to get rid of this. Again, you do not need to have that in there. That was just for our reference for this video, but you do need to have all of the variables listed over here with their known or unknown shown with a question mark values. And then on the right side, make sure that you first list the equation that you're using, substitute values in, and then box your final answer. And for two-parters, having a line like this to delineate between the two parts really makes it helpful to read your work. If you have any additional questions, please make sure to talk to your teacher. Thanks for watching. Have a good one.